Hi everyone, welcome to our next lecture. The lecture will be on the derivative, which is something that will be very important in calculus and in your role in the subject of healthcare as well. When we look at a derivative, we need to look at the slope of a line. And the line that we're going to look at is going to be a straight line. We have this equation, y equals mx plus b. The m is going to be the slope. Slope is classified as rise over run. And the point, 0b, is called the y-intercept. And we're going to see some examples of where it intersects the xy axis. So when we look at this, it's going to see where it intersects the y-intercept. So if you get this example, y equals 3x minus 4, 3, the number in front of the x, is the slope. Negative 4, that's where it's going to intercept the y-intercept. So let's put some of this to the test. Y equals 2x minus 1. So that means rise over run, 2 over 1. So that means you go up 2 and over 1. Negative 1 is where it hits the y-intercept. Y equals 2x. So there's no y-intercept there. So that means it's probably going to be 0. Right here's where it hits the y-intercept. 2 over 1. So you go up 2 over 1. That's how we find the slope, rise over run. Y equals 2x plus 1. So it's going to hit the y-intercept right here at 1. Okay? So you look at, again, the slope, up 2 over 1. So those are examples of lines that have positive slopes. Now if we look at graphs that have negative slope, it's negative 2, so down 2 to the right 1. So let's say we start right here. 1, 2 to the right 1. So this is the slope, this is the y-intercept, negative 1. Right here's the y-intercept. Here's the y-intercept. Or, I'm sorry, y equals negative 2x, and there's basically 0 right there. Y-intercept 0, negative 2. So down 2, 1, 2 over 1. There's your slope. Negative 2 plus 1, y-intercept. So if we look at this, here's the y-intercept at 1, negative 2, there's your slope. So those are examples of lines with negative slope. Now we have an example. A healthcare professional has looking at weekly pay depends on the volume of medical sales, let's say. If she sells X units of the good, then her pay is Y equals 5X plus $60. So it depends on how much she sells is where we look at that X. Give an interpretation of the slope and the y-intercept. So that means we can see she's paid $60 a week. And it depends on how much, 5 times each unit is how much she gets paid. So let's look at a solution. Let's graph it. So if we look at it, 60 is her pay. How much she sells, how much her sales of these medical devices determines how much she'll have. If she sells 100 units, so 100 times 5, that's 500 plus 60, so $560. So the slope is 5. Since the numerator of this fraction represents the amount of change in her pay relative to the amount of change in her sales, denominator, for every 1 sale that she makes, her pay increases by $5. The y-intercept is 60. So this point suggests that when she has executed 0 sales, she's still going to sit $60. So that's her base pay. So that's a great example how you interpret it, the equation of a line. And in more videos, we're going to continue to develop this further.